with consensus theorem to recap this, where you'd have something like this, okay? And sometimes when you have, guys, what was the theorem that we had, or the expression we had that we ended up simplifying down to 2? What was it?
I'm gonna. I can send her a picture really quick.
Yes, I think.
Oh, did somebody throw a picture in the chat?
I did, and then I'm also gonna send what like all of the notes that we have thus far, which is just a little bit different than what's on there.
Yeah. Okay.
Thank you.
All right, Kelly.
That. Yep.
So anyway, all right. Does that work?
Yep.
So Richard Hamming is a genius. Well, he was. He's dead now. But anyway, what pet does he have by his side there?
Kitty cat.
A kitty cat. Okay. And I don't care what you say, Brooke. I'm right.
I said nothing.
Oh, you said something. Okay. Guys, we can't combine anything here, right? We can't. So these are all prime implicants. Okay? They all, if any of these terms evaluate to 1, the function is a 1. So therefore they are implicants. Are they prime? Well, yeah. You can't take out any of the literals. Okay? Like this guy would be, what's the domain? PBS. So this is P naught, B naught. Yes, no? Yes, no?
Sir.
This is B naught, S naught. Yes, no?
Mm-hmm.
And this is P S naught. This is P naught. I'm sorry. My dyslexia is acting up. P naught S and P S naught, right? Did I do that right? Looks right.
Mm-hmm.
Lastly, of index 2, we have a grouping that is BS, right?
Mm-hmm.
My
and
initials.
we have, yes, very true.
Best initials ever.
And then we have PB. Okay.
Great things.
BS
Question is.
Oh, sorry. Go ahead.
No, good. What were you going to say?
I said BS is some good initials, but I knew a girl in high school whose initials were ASS.
There was a student by the name of Adam Sable. Some of you may or may not know him. I don't know. Incredibly smart. He graduated with like a 3.95 or something like that. He's the student who, on the first opportunity in this class, it was a take home, right? It was pre-COVID, but it was a take home. And, on a take home, it's open book, open note, right? I can't police it. The professor can't police it, right? So we have no idea if you open your book or not. So we just say, okay, go ahead and use your textbook, use your notes that you took. So that's standard for a take home. Anyway, well, Adam couldn't remember what I said as to the allowable things that he could use to complete it. So he just sat up in his bedroom and did it without opening his textbook or his notes because that was the most restrictive. So he figured he was good. That's Adam. And he still set the curve. How'd I get on that? Oh, Adam Sable. So anyway, Adam, incredibly intelligent, really, really super great guy. But he ran the, you guys at Toledo, don't you have some area that has a few computers, but it's kind of your hangout area where you can eat lunch, socialize, that kind of thing?
Mm-hmm.
I don't remember what is it called, the engineering lounge or something like that?
Yeah, I think that's what it's called. They just redid it.
Yeah, they just redid it. So, well, there's a similar area at UPRC, and Adam ran the snack fund. He'd go to Costco or something like that, and get Pop-Tarts and all these things, and sell them for pretty much a couple quarters, if that, in the Sun Lab, which is the lounge area. So on a on one of the opportunities that I gave, I think it was in statistics. Anyway, I one of the questions cited. Okay, which of course is abbreviated the S.
Mm-hmm.
Oh, wow.
Adam liked it. I liked it too. It was funny.
That's a good story.
Adam definitely liked it. I miss Adam. He's one of these guys that'll solve a 5-variable Quine-McCluskey because he was bored.
Adam has
Let's
no
see.
kids, obviously.
No, he doesn't. No, he's not married. I think he was dating a girl. He probably still is, but I don't know. He's moving down to Florida for a month to do some nonprofit work or something like that. What do you want to call these midterms, guys? Or these implicants?
A, B, C, D, E.
Okay, fine. So this is A, B. I don't want to erase the Carnot map. C, D. This is E, and this is F. Okay.
Oh my God. Fine.
So, group number A include what are the midterms we have again? Somebody's having
0.
fun.
0,
Keep on
1,
going.
4.
How about 3?
3, 4, 6, 7.
So,
Thank you. Okay.
out of order.
Group A includes 0 and 1. Yes, no?
Mhm.
Is consensus theorem just another word for like Quine-McCluskey?
No. The consensus theorem is a way of proving that, guys, in your notes, what was the expression that we reduced to 2 terms, to 2 products?
R naught T plus ST plus RS.
I don't know what plus is.
Oh.
R naught T plus.
Oh, what's
Ord
plus?
Yeah, I know. ST ORed with RS. Is that right?
Yes.
Mhm.
And we proved that it was equal to R naught T ORed with RS. Yes, no?
Yes.
Mhm.
We proved the consensus theorem says that if you do a bunch of stuff, which we did, it was just using a Carnot map or Boolean simplification. This term is redundant.
Okay.
It's that second picture that I sent in the group thingy. That like worked out portion of it.
After we get done with this, I was hoping we could look at K maps and because I noticed in the class a lot of times you look at them and you just know which term is redundant. Like I understand how to put the marks in there and group them together, but when it comes to determining what is redundant, I don't understand where you're getting those like letters. I do a little bit, but
Okay.
yeah.
We can do that.
Okay.
Absolutely, we can do that. No problem, Kylie. Would that make you happy, Kylie? if we did that?
Yes, absolutely.
Well, it's all about making you and your lawnmower happy, Kylie. One of these days we're.
I missed some of this. I was caught in a very inconvenient situation.
You just defined my life. It's just one inconvenient situation after another.
Yeah, that's being
So
adult.
this is, what's that?
It's being an adult for you.
Yeah, that's everyone's life after like 18.
You know, I don't recommend adulthood to anyone at all. I highly discourage it. I really do. The whole adult gig is pretty much one completely and totally ad-libbed situation after another.
My
Yeah,
dad
but they
said his
said
Halloween costume this year is going to be an adult. The scariest thing about
What's that, Kylie?
My dad said his Halloween costume this year is going to be an adult. The scariest thing of all.
You're going to be an adult?
No, my dad.
Oh, your dad's going to be an adult.
Yeah.
That is kind of scary. Okay. Yeah, I told my daughter that, my youngest daughter that. Shoot, she was about 16. Actually, I told my oldest daughter that too. And the oldest daughter kind of said, "No, I want to grow up." I'm like, "You are going to regret that." My youngest daughter said, "Oh, I'm never moving out of here, Dad." That also had me concerned for a while. Anyway, they are both married and don't live too far from us. Have sons. So I think we're ready to figure out how to simplify this thing, right?
Let's do it.
Let's do it. So we can realize the function if. Oh, this is going to be nasty.
Mm-hmm.
We have one or the other, or both. We will be able to grab midterm 0, right?
Yes.
Midterm 1 is aord with. You hear that? And then we have C-ord with E. Yes, no?
Hi.
Do you agree with that, Carson?
Yes.
Okay. As long as you agree, we are going to proceed. Then we have B-ord with D. That's midterm 4, right?
Yep.
If you have trouble keeping track of what's what, guys, you can always just do this. This is midterm 0, midterm 1, midterm 3, midterm 4. What's 6, guys?
D-ord with F. No? Oh my jacking. Oh my gosh.
The E
Wait a
is
minute.
bit
Did I screw something up?
Yeah, you got too many X's
No.
in that one, don't
No,
you?
I do.
The amount of X's is just not aligned with the.
It's D and F, right?
Yep. It's E and F.
It's not E. It's not E, right?
There we
Now I got it right, don't I?
go. Mm-hmm.
Mm-hmm.
But you need
And
to know that E was supposed to go in the last slot.
yes, that's what I screwed up. This is D-ord with F. This is E-ord with F. Yes, no?
Yes.
So that's E-ord with F. Not to be confused with the. Is that a Disney thing or a Winnie the Pooh thing? Eeyore?
Winnie the Pooh. Ow.
Yeah.
It's Winnie the Pooh? Okay. All right. This is midterm 6 and this midterm 7. So we have all the midterms grabbed. They are represented in at least one of these groups. So what do we do, guys?
I guess you distribute. and make a mess.
This goes to AORed with BC once you distribute it. Okay?
Well, how do you do that? Oh, never mind. I lied. Nope, we're good.
Does anyone have any questions how this term ANDed with this term goes to that? Are there any questions at all?
Not like that.
Other than Carson, are there any questions at all? We good?
Good.
Mm-hmm.
Okay. Now, the easiest way to do this is to see what we can combine, okay? These two, C and E, well, we already used the term involving C. Can we combine this? Can we and this with another term involving E? Sure. These two guys, right?
Yes.
If we do that, what about these two guys?
You can do D's.
Okay. So we and this term, C-ORed with E and E-ORed with F. And once you do that, you're going to get an E ORed with C ANDed with F. And once you and B ORed with D ORed with F, you're going to end up with D ORed with BF. Okay? So then we got more work to do, and it's going to be nasty. And this stuff out. Oh, God. This is going to be an AE ORed with A, CF, ORed with B, CE, ORed with BCF, right?
Mm-hmm.
Okay, those two terms. And this nastiness is ended with D ORed with BF. Once you and those two things to get together, what do you get?
Ugh. A, D,
AED, right?
AEAFD.
Okay, hang on. AED, right?
So when we're really quick question, this is kind of like weird and random, but like when we're distributing this, and should we swap it instead of AED? Instead of doing AED, should we do ADE or no?
That would be preferable to your sanity, more than likely.
I didn't know if it was like you should do that, or if it was like
you don't have to, because but if you do, it makes redundancies a lot easier to pick out.
Okay.
Because everything's in order, right?
Yep.
If you had an EAD somewhere over here, it may not jump out as quickly to you that they are indeed redundant, right? One of them's redundant. Does that make sense?
Yeah.
ACDF.
That's what I get. And then we got a BCDE. Yes, no?
Yep. BCDF then.
Now that I told you to do it, I can't do it myself. Okay. And then what do we have?
Same thing with an F on the end.
I hope to God this works out. Ordered with. Does that give you a warm fuzzy or what?
I don't know if
Ordered
that's what I
with
call it.
ABEF, right?
Yep.
ABCF ordered with BCEF ordered with BCF.
You said BCF?
I believe so.
Okay, BCF. This guy's redundant, right?
What?
You got BCF here, yes?
Mm-hmm.
You got BCF here. It happens to be ended with A. This guy goes away.
The whole entire thing?
Yeah. Do the Boolean algebra. You got BCF ORed with, right? So factor out, or I guess distribute out a BCF. This is going to be A left over, ORed with 1. Yes, no?
Mm-hmm.
Oh, yeah, duh. Okay. Yep.
You buy that, sweetheart? You buy that, Brooke?
I buy that.
All right.
What did you call me? Spirit?
Nothing.
Mm.
What else can we do that kind of nonsense to?
BCF and
Doesn't this go away?
there's several of them actually.
This goes away, doesn't it?
Yep. So does
Yep.
the one right before BCF.
Okay.
I think that's it. I might be lying.
Then we screwed something up. BCF is one of the solutions, right? Right? What are the two solutions we found? I'm going to erase this stuff up here, okay, guys?
Yes.
You know how to convert a POS to SOP and vice versa.
Let me just get a screenshot really quick.
Absolutely.
Sorry. I was trying to copy that you were. Yeah, sorry, I'm just a little behind, just trying to keep the notes. Okay.
No, you're
good.
fine. You're fine. That sounded like Marissa. Is that right?
No, it's Kylie.
Oh my God.
It's because I got here 40 minutes late.
Man, I was on fire
You were
yesterday.
on a roll. It's okay. Everybody's got to get knocked down sometime.
Are you going to get up again? Is the real question, though.
Is the real question.
I don't think so. No, I am hurt that I screwed up. Go,
Just take a nap.
All right, you're all good to erase it now.
go. Question.
So that one has the line over the top again. The one you have circled, you're about to erase, all the way at the bottom of what you're about to erase. Yeah. So it's like is there another inversion that needs to be done before that's like the final answer, or what you circled is the final answer?
What I circled, we did a double bar here, right?
Yeah.
On top. That's this. We started originally with this. Okay. And
Yep. I did it like they switched. So at the bottom, you have like at the top you have the P ORed with the S now, and at the bottom the P is now.
I understand. I'm trying to explain it, especially for those who came a little bit later. So you double bar it, right? You haven't changed anything, so you can double bar it. Then you can apply De Morgan's using the lower of the two double bars. So you apply De Morgan's, okay? Then you have three individual quantities. These are sums. You can apply De Morgan's again to each one individually. That gives you the part that I circled, but this whole expression is inverted. Therefore, you have to bring that bar down. You can't just get rid of it. You have to bring this bar down. So you could generate this function using what? 3 AND gates and an OR gate, right? 3 input OR gate, right?
Mm-hmm.
And then you just have to flip it at the end.
So I think
because of this.
So when we're giving our final answer for something like that, we wouldn't just leave that bar up there. We would flip them then, correct? I think
You would leave the bar up. If you were asked, you're given this and asked to convert it into a sum of products type of expression. This is sum of products, clearly, but you still have to invert it in order to not change the functions
order to
minterms
keep-
that it includes, right?
So it's
It's
okay
value.
to leave the overarching bar up there.
It's what?
It's okay to leave the overarching bar up there.
It's not only okay, it's necessary. If we don't have it, these two expressions are opposites of one another.
Yeah, it's the complement of it.
Would
Yes.
we be able to insert, like all of them underneath it then like the P would, and then S not rather than the P not S? We wouldn't be able to invert them like individually.
What, these? No. That would be different. No. Can't do it.
Okay. All right. Thank
Yep. Good question. Okay, can I get rid of this now? Are we good?
Can I just say one more thing just to make sure my head's where it's at?
Sure.
So we would be inverting then the sum of those products. Never mind, I answered my own question. We're good.
Okay. Going once. Going twice. Last chance.
Okay.
All right. Now, what did I need? Oh, let's write down the two solutions that we know are correct. Okay. We know there's two, and we know what they are, kind of, sort of. What was this? I erased it. What was this form of the expression? We had BS, right? Ord with, what's this one?
It was P or with S not
You
anded
mean
with
anded, right?
our like final
Yes.
product.
Yeah, the final thing.
And then PB.
How about P not, B not?
Wait, I'm so confused.
P not, B not. This bottom row in my table.
Yeah, I
Which are-
thought
Yes, no? Right? We good, Brooke?
I don't know. So where did we come? Like, where did that come from then?
Where did what come from?
I don't have that. I don't have that wrote down anywhere on my
I don't
paper.
know if I'm wrong, but so the very last thing that I wrote down was P not S with plus B not S not plus PB, and then all that with the bar over it. So
He's getting it from the car map. To check
There-
the answer.
There are two
Well, what
solutions, right?
was what you just erased completely separate from the Carl map?
No. Yeah.
Okay, so-
Yes. Had nothing to do with this.
Okay.
So the other form of the expression is equal to PB, ORed with, wasn't this the one with B naught, S naught?
Mm-hmm.
Yes, this term right here. And which one do I not
B not
have?
S.
We have the B naught S.
Didn't we get the car
P
map?
not S.
SOP
It's P naught.
Yes.
Yeah. Okay. These are two solutions that are correct for some of the
Okay.
midterms.
That's
What's
why I
that?
was confused because that top one is the second one that we found. That's why I was lost. I
Okay.
didn't write that one down.
Are we good?
Yep.
Mm-hmm.
Right? So let's bring this horrible expression up here. I think there's a screw up somewhere. I really do. P naught, B naught is term A. Green sticks out, right? You can tell the difference between blue and green.
Yeah. It's
That's
a lot better on the board too.
that's That's P naught, B naught. The group B naught, S naught, that's group number B. The group P naught S is group number C. The group PS naught is group number D. The group BS is group number E. There's your ADE, guys. Oh, I forgot the BCF here. And what's PB? PB is group number F. Okay. So we have found ADE is the first solution we have. BCF is the second solution we have. These should have all canceled, and it's probably because of something I screwed up in down here, or when we did Patrick's. I probably totally screwed that up. Although I don't know where. Anyway. One of those E's is an F or B's is a D, or so, I don't know. Something like that. 4 is in B and D, right? 4, B and D, yeah. Okay. But anyway, we should have these three with four terms in them. They should all they should all go away. And again, something screwed up down here. A word with BC, it's probably not worth spending a huge amount of time over. Yeah, we screwed something up, or I screwed something up. Sorry, guys. Okay. Do you want to do a 4 variable with redundancies, guys? Talk to me.
Yes.
I thought one of you, was it Kylie, said something about being able to figure out what's redundant and what's not. Yes, no?
Yeah, with car maps.
I'm sorry?
She was asking about car maps with redundancies.
Okay. Ready to roll?
Yeah, sorry,
I
it's
can,
my mic to unmute. Yeah,
I can get rid of this, right?
let me just take a screenshot really quick. Or
Go ahead.
okay.
Go ahead. No, don't apologize.
You're good. Got it. You're good, everybody.
Okay. Is this helping you guys, by the way?
Yeah.
I'm very sore that I was so late because I feel like I would definitely be lost right now.
Well,
I had sorry, quick question before you erased everything. How did you, in the bottom left corner of the screen, how do you know what to cancel out? I know you kind of did the Boolean algebra, but could you just go over again that real quick? Or
absolutely, no problem at all. No problem at all.
Thank you.
I'd like to find out the error.
I'm trying to figure it out now.
It's not jumping out at me.
I'm betting it's when we distributed down there at the lower right.
Yeah, I'm kind of thinking the same thing. I am, but I'm not seeing where the error is. So, and all of this looks plausible. I mean, there might be an X somewhere in the wrong spot, but I'm kind of thinking not, because each term has 2 min terms in it, right? And each min term is included in 2 of the implicants. That's right. That's right, given this. And that's right also according to the Karnaugh map, right?
Mm-hmm.
So, like 8, I don't know. I wonder if we could use the consensus theorem. I don't know, guys. Something isn't right, but
I just went through all the distributing too, and it's right.
then that means this is probably wrong. There's probably an error here.
No, I can't find it.
Maybe.
So here's the question. If you were grading yourself on the exam, would you give yourself partial credit?
Oh, I give myself partial credit.
Okay. But how much, you think?
This is correct. I'm relatively sure this is correct. Okay. So in a problem like this, where you're given a book, here you go. Here's your midterms. Do Quine-McCluskey to find the prime implicants, then do Petrix to find the irredundant expressions. Usually I grade something like that, like 2/3, 1/3, or something like that. If there's more, then obviously I tweak it. So I would definitely get 2/3 credit for this. I would take off, I don't know. So let's say it's a 30-point problem because that makes the math easy. So I get 20 points for this because I'm pretty sure it's right. I would get maybe 6 out of 10 here. So I'd get 26 out of 30 for the problem.
That's not too bad. And that just brings to mind how hard it is going to be to grade all those exams. I wish you very much luck.
Let's see. Who's had me before? Andrew has had me before. Anyone else? When it comes to
questions,
let's answer the previous one, or at least address the comment. Andrew, you there?
Yep.
Be nice. How hard of a grader am I?
Oh, you're very fair.
Thank you. I do try to be. Seriously, I do.
As long as you put in a good effort and you understand most of it. If you made a mistake, I'm not feeling too. That's okay. I'm sure mistakes or a couple will happen. I'm
this
not
doesn't
feeling too
look
bad
right.
about that.
No. So, yeah, thank you. Something is not right. We had 6, we had 7. Do we have 4? Yeah, 4, 6, 7. We had 0 and 1. We didn't have 2, we had 3, right?
Mm-hmm.
If you numbered your rows in the Carnot map the way we've been numbering, is this the Carnot map that you get? It should be. Looks right.
Yeah, it is.
Okay. So, for example, let's plot ACDF. This is one of the solutions we found. I don't know if it's right or not. Where's group A? That's 0 and 1, right? Where's group C? This is group C, right? 1 and 3? Right?
Actually,
Yes.
if we mirror that back, I think it was actually wrong.
I think so. That's what I was so confused at the beginning because I have it different on there. But I also did it the other way, so I think that. Remember, I said I messed my K map up.
Yep.
It takes me a second to do the K maps. That's why. I think I had 0, 1, 0. That's probably not right either, though. I'm just gonna shut up. We'll let you figure it out.
Why? Because I'm batting 1,000 for all of the problems I've tried to solve today. So we got that
this
one.
is not my strong
You know
suit.
what? You know what? It's a valid irredundant expression. What's F, guys? 6 and 7, yes, no?
Mm-hmm.
Guys, are there any redundancies?
No.
We found an irredundant expression using prime implicants. That's valid. I was thinking there's only 2. It's a solution. It's as simplified as far as it can get.
Huh.
You want to look at B, C, D, E?
So, how do you, what?
Okay, we know that ADE, we know this is a solution. We know this is a solution. We just proved this is a solution, guys. We just proved it. This, I would be willing to bet money, is also a solution. Put the midterms in. Okay. Now, what's group number B, guys?
0 and 4.
Okay. What's group number C?
1 and 3.
What's group number D?
4 and 6.
How many?
4 and 6.
And what is group number E?
3 and 7.
It's also a valid solution. Amazing, isn't it?
So like, no, you're good. Go ahead.
We're gonna cover that next. If you have any don't cares in the midterms, it doesn't matter on Quine McCluskey, okay? It doesn't matter. That is a don't care. You still include it. It's Petrik's where it's excluded. All right. You always exclude it on Petrik's because you don't need it. Well, with K-maps, it's a little bit more subjective, right? That's the problem with K-maps. You include it where it helps you. You exclude it where it doesn't. It is. Yeah.
Yeah, but you need to keep it which way you flip it once you actually use it that way, right?
If it's a 1 used in one group, then it's a 1 used in all groups.
Same with
That
0,
is part
right?
of. That is a part of.
Mm-hmm.
Right? For example, if this was a don't care in this Karna map and this one only, if this was a don't care, well, we used it as a 1 here, right? Well, therefore, it's a 1 in this group as well. Okay? So, did I answer your question?
Yep.
All right. I was just going to, real quick, guys, because we're absolutely beating this problem to death. I was going to find this form for you. And then I'm going to ask the old, age-old question, which is better or which is best? So we have term number A, right? A, D, E, F. We have term number A. Which midterms does that include?
0 and 1.
0 and 1, yes, no? Okay.
Yes.
What's term number B?
0 and 4.
That's the wraparound. Okay. Term number E?
3 and 7.
And term number F?
6 and 7.
Wow. Okay. We didn't make a mistake. We didn't. None of these implementations that have four implicants, none of those have redundancies. That's why we couldn't cancel them out. They're valid. Okay, which is better? Which are the good ones or the best? Which are not so good?
Probably ADE and BCF.
Okay, where do you get that? Prove it. Prove it.
No.
I just came out of an all-day design review today, okay?
I guess they're easier to work with.
What's that?
I guess they're just easier to work with.
Well, we have a objective, right? Objective, which means it can be proven. It's not up to interpretation or opinion, right?
Mm-hmm.
We have an objective way of determining which SOP expression is better than another SOP expression, right? We have an objective way of doing it. Do you remember what that is?
Not really.
Don't you remember talking about cost?
Yeah.
Do you remember that, guys? Everybody? What's the cost of this expression?
4.
What's the cost? First off, we need the Boolean expression for it. And help me out, guys. What was it? ADE, so it was what? P naught, B naught? Or with what? PS naught? Or with ADE? BS? Is that right? Help me out, guys.
Mm-hmm.
Is that right? That was one of the forms, right?
Yeah.
What's the cost? Do you remember?
6 plus 3n and 1 over r.
Okay, who is this? Can I ask?
It's Ngọc.
It's who?
Ngọc. I'm an Asian student, so.
Oh, how do you pronounce your name now?
It's NGOC. It's Ngọc.
Now, okay. So, did I say it right? Now?
Yeah, nearly.
Okay. I'll work on that later, okay? So,
Okay.
Is that all right? You are dead right. It's 10. Are you the student that joined a little bit late?
Yes, that's me.
Okay, I remember you. You seem to have caught up rather well. Good job.
Thanks.
Yep. The cost is 10 units, guys. Okay. What's the cost of this expression? BCF. Well, when we found it, it was, what's B? What's B?
D naught, S naught.
Or with
Let's see.
P naught, S.
S.
Or with
PB
PB.
and J.
What's the only if we want to. J is equal to 1 for this problem.
J and J
Okay.
not.
Okay.
What's the
so real
cost?
quick,
10 again.
Okay, what's real quick?
you can finish the cost first.
Cost is 10. Yes, no?
Mm-hmm.
We have 6 literals. 1, 2, 3, 4, 5, 6. We have 3 AND gates. 1 to generate this guy, 1 to generate this guy, 1 to generate this guy. And then we have 1 overall OR gate. Yes, this is a 3-input OR gate. They have the same cost as 2-input OR gates. So it's still just 1. Both of these expressions have a cost of 1. All right, 1. They have a cost of 10. Okay. So it wouldn't be ignoring anything and everything else, just what we have in front of us. It wouldn't matter which form of the expression you implemented. They would both give the same results. They have the same cost. In fact, indeed, they have the same form, right? 3 products summed together. 3 products of 2 literals each summed together. So it literally doesn't matter which one we would choose. Somebody said somebody asked a question or gone.
Yeah. So it's kind of unrelated. I understand what you're saying about this. But below your Klein-McCluskey, you have, like I said, I came in late, so sorry if this is dumb. But you have all of these ADE plus ACDS, all that down there.
Yeah. That came
where
from
did
this expression here.
Okay, so you simplified that. And you got those expressions. Let me just double check and make sure I'm reading it right. So in the one that's crossed out, that's so after ABEF, that's plus ABCF, right?
Yes, ABCF.
Okay.
And we crossed
All right.
that off because we have BCF.
Okay.
So this guy goes away. This guy goes away. That guy went away. And that's it.
Okay. And so I'm just trying to catch up in my notes. And then
Yeah.
So you got this expression from looking at your Petrix, and then you got the expression to the right of Petrix, you solved it, and then you simplified that over there on the left.
Run that by me again.
Sorry. So you got your Klein-McCluskey, and then you
Right
do
here.
the Petrix map, and you got those terms to the right of the Petrix in the parentheses. You got all those from the Petrix, and then you simplified, and then got those terms all the way to the left, and then did your canceling. Okay.
Yep.
All right. And then those
We're going to do this. Go on.
Sorry. Those three K-maps are just three different ways that you could have approached the problem, right?
One is this implementation. I wanted to show you graphically on a K-map what would happen. So you can see there's no redundancies.
Yeah.
It's not the best way of doing it, but there's still no redundancies. There's no redundancies here either, nor here.
Okay. Yeah, I get you.
Okay.
I'm still having a hard time.
I beg your pardon?
I'm having a hard time understanding why we crossed off the one that has the ABCF, because there is, it's not like necessarily completely redundant. So like, how do we know when we can cross them off and when we can't if we're crossing off things that are still there?
Okay, I don't know if you caught the example we did to show that this goes away.
Yeah.
Factor out a BCF out of this guy and this guy, right? Yes, no?
Okay.
Do you buy that?
Yeah.
Well, what does the quantity in parens go to? One word with anything is...
Is it a 0 or a 1?
Well, yeah, those are the choices.
Right.
But one word with anything goes to 1, yes, no?
Yeah.
Okay.
There it is.
Yep.
Right?
Yeah.
So this goes to 1. So that leaves us with just BCF. This guy goes away. These two guys ORed together is equivalent to this guy all by itself. So we cross off this. By the same logic, we cross this off because it has B and with C and with F. This guy goes away because it's got B and with C and with F. So, okay, those are the kinds of relationships when you get your expression using Petrix. These are the kinds of relationships that help you simplify the expression a lot. Okay. Are we done with this one? Talk to me.
Yeah.
Okay, ready for something bigger and better? Well, not necessarily better, but certainly bigger. Yes, no?
Yes.
Okay. I might need... Do you want to do a 5 variable one?
If we could, I know we're working on one in class. If you want, we could.
Do you want to
pull
finish
up
that
just
one?
an idea. Yeah, I was saying because we don't need to start a whole new one since it's such a long process. we could just probably finish that one and get a little more
Oh,
clarity.
it's not a long process. It only takes me about an hour.
But so we left off with the second pass. We hadn't finished, but I kind of got that, and then you showed us a little bit of how to start the third pass. And then
I would also, I would like to. We didn't have time to do this yesterday.
Yes.
I would like to show you what it looks like on a Karna map. I know it's a 5 variable one, so you have to think 3D, but I would still like to show you, okay, graphically.
Do you want me to put a picture out there or something of what was already
No,
written?
I would like you, I do need someone, possibly you, that's fine, to give me the sum of the midterms, right? F equals, what was the domain, by the way?
What do you mean by domain? Like, it was VWXYZ.
Thank you.
And then, yeah, the sum of the midterms was 2, 3, 6, 8, 9 is a don't care, 10, 11, 12, 13, 14, 15, 18, 19, 21, 22, 23 is a don't care, 25, and 26 is a don't care, and then 30.
Yes, no? Okay. Now, here's what it would look like, and I'll do my best to make it clear for you.
After the K-map, if we also could do a Petrix, that would really help.
Oh, yeah, well, we're going to finish the Quine-McCluskey, and then we'll do Petrix.
Yeah,
Sound
that's
good?
what I meant, like after we finish the whole thing.
My artistic abilities are pretty much non-existent, guys. I apologize for that. My wife's the artist. Okay. So if we set the upper plane equal to V equal W, lower plane is V equals 1, okay? If you don't like it, flip them. I don't care. Okay? Now, let's see. Hot pink. Hot pink stands out. So we're left with 4 variables. Yes, no? W, X, Y, Z. If we do it the way we've been doing it, we would have WX specifying the rows, Y and Z specifying the columns. Do you see that? Yes, no? WX specifies the row. It's just like the 4 variable Karna maps, right? It's just a little slanted now.
It just translates, and then those numbers obviously translate to the bottom part as well.
Yes, they do. But if you do it this way to get it out of the, this is kind of like no man's land, right? We're going to have lines going back and forth between the 2 planes. So if you put your labels down here, you got to be careful. This is YZ and this is WX because the rows are here. So Wx corresponds to the rows, guys. Right? Yz corresponds to the columns. So the leftmost column is 0, 0. Next is 0, 1, then 1, 0. Okay? You buy that, guys? Talk to me.
Yep.
That's so good. Oh wait.
All right.
The last thing you said was, I don't know why I said that because I just blanked out. V equals 0 is the top and V equals 1 is the bottom.
Yep.
Okay.
And V is the most significant bit in the midterm representation, right? The binary representation of the midterms. V is the most significant bit, right?
Mm-hmm. Yep.
So if V equals 0 for the top plane, then midterms 0 through 15, 0's here, 15's here. There in the top plane, midterms 16, which would be right here, right? V equals 1. Everything else is a 0. That corresponds to this guy right here. That's midterm 16. Midterm 31 is here. So the bottom plane, because V is set for midterms in the bottom plane, that's midterm 16 through 31. Does everyone understand that? Or anybody not understand that, I guess? Yes, no? Talk to me.
Yep. Because you had 16, right?
Yeah, just at 16. Yep. So put the midterms on here. So 2's here, 3's here, 8 is down here, 9's you don't care, right, guys? Then we have 10 and 11. Then we have 12, 13, 14, 15. Should I choose a different color other than green? Put the ones up there. Talk to me. I don't know how well it stands out. How about if I use red? Would that work? Is that standing out a little bit better?
Good enough.
Well, it has to be the best.
I'm just over here trying to draw a cube. It's not going that well.
Okay. So downstairs for vehicle 1, we have midterm 18, 16, 17, 18's over here, 19's here, 16 plus 3, right? Then 20, 21, 22, 23 is I don't care. 25 is right here. This is 24. 25, 26 is a don't care. And then we have good old 30. Okay? It's kind of sort of looking like we're going to have a group of 8. Yes, no? Just looking at the K map. Right here. I don't see any other groups of 8. I could be wrong, easily wrong. But I don't see any other groups of 8. I see a few groups of 4, right? We got a group of 4 here. We have a group of 4 here. This group of 4 can't be combined with anything up here because we're missing these 2 midterms, right? We have a group of 4 here, do we not, guys? Talk to me.
I think so.
Remember, this plane, this min-term is adjacent to this min-term. Okay? The WXYZ stuff is the same. V changes, so it goes away. This min-term right here is adjacent to this one. And of course, they're adjacent here and here. So therefore, we have a group of 4 right here. Are we going to use it? I don't know. We have a group of 4. We have a group of 4 here. These 2 guys combined with these 2 guys, right? These 4 are adjacent. So we have that. What do we do with this guy? What do you think? Is this min-term here adjacent with anything? Isn't it adjacent up here with this guy that don't care? Right here, these 2.
So you compare those 2 if they're adjacent.
Yeah.
Just a group of 2.
Yep.
Okay.
So they'd be a pair, just a pair of 2, right? We can't do anything else because this guy has all sorts of friends, right? This one has none. You can't pair it with this one. You can't pair it with either one of these, and you don't have the wraparound, so you can't pair it with anything up here. So the only thing this guy can be paired with is up there, the don't care. So in that case, the don't care helps us, right? What about this guy? What would you do? Can you pair it with anything up in the upper plane?
Which one again? Sorry. I was ready.
This one. What do you think, guys? Help her out.
Could be the one directly above.
Well, the one directly above would be this one, wouldn't it?
Oh, okay. Yeah. Hard to see.
He's not there. Nobody home. So can't go there. Can't go up. Can't go to the left. We can't go down. We can go to the right, though, and use this don't care as a 1. So we can pair these 2. But other than that, we can't go any further with that one. So you guys ready to do Klein McCluskey?
Yeah.
Talk to me.
Yeah, I'm ready. If you want, so you don't have to do the whole.
Well, we started it, right? So you just tell me what we did, so I don't have to think, okay?
Yeah, that's what.
So we have index, index, min-terms, and first pass, right?
Mm-hmm.
Do we have min-term 0? No. We have min-term. We have of index 1. We have min-term 2, right? What else do we have?
8.
What else do we have?
That's all for midterm or for index 1.
Okay, we don't have 16. Okay. How about 2?
2 is 3. 6.
Keep on going. 6.
Yep, 6. And then 9, don't care.
What's next?
10. And then 12. And then 18. That's all for index 2.
That's it?
Yep. For index 3, it's a 11. 13.
How many? 13?
Yep, 13. Oh, sorry, you missed. I said 11 first. Sorry. 11, 13, and 14.
I heard you right. I just didn't write correctly.
Yeah. And then we got 19. And then 26, don't care.
How many?
26, don't care. And then we got 21. 22.
Oh, 21? Hang on.
No, you had the 26, don't care, right? And then after that was 21. Is there somebody's mic?
Oh, we're in index 4 at that point, are we not?
No, these is all index 3. There's only 3 numbers for index 4. I think somebody's mic is open and it's making
It is. Okay,
so
of
we got
index
11.
3, we got 19.
Yep, and then
Then
after
we
that
go to 21, do we not?
I have
Yes.
written down 26. I might have written it down wrong.
I think yesterday I think I missed one. So the next one's 21. That's 20.
Oh yeah. I just wrote that in the wrong place for some reason. I see why you were confused.
Then 22.
And then 25 after that, and then
25.
Yep.
And then 26, right? 26 is a don't care, is it not?
Yep. Sorry about that. I don't know why I
You're
wrote it down in
okay.
the middle.
You're
like that.
okay. You're okay. Okay. Are we done with 3?
Yep, 3
Yes.
is good.
So index 4, what do we got?
15.
15.
Don't we
Yep.
start with 15?
Yep.
Yes.
What's after 15?
23.
23.
23, don't care?
And then 30 is our last one.
And 30, right?
And that's all.
Okay, sanity check. How many terms do we have up there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do we have 19 listed? Pretty sure we do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep. It's not a guarantee that we're right, but we sure stand a good chance that we're right. Okay, first pass. So we combine 2 and 3, yes, no?
Yep, 2, 3. Do you want me to start listing them off?
2 and 3. Yeah, go ahead. What's next?
2 and 6.
2 and 10.
Yep, 2 and 10, and then 2 and 18.
Then 2 and 18. Okay. What can we combine 8 with? How about 8 and 9?
No, I think 8 and 10. Oh, I missed that last time. 8 and 9 is.
Right?
Yep, 8 and 9.
How about 8 and 10? You already said that, right?
Yep, and then 8 and 12. God, I missed a lot.
8 and 12? Yes, no?
Yep.
And then 8 and 18 can't do it. So, okay, we're done. Oh, I forgot to mark 8 off.
That's all I
Okay.
have for the first pass. Or the
First pass, index 1 with index 2, we're done. Now, we try to do 12 with everything, right? Don't look at 11. I'm sorry. Why am I starting there? We try to pair 3 with everything. Can we pair 3 and 11? I think we can.
Yep,
Can we pair 3 with 19? Yes, no?
Yes.
And that's it for 3, is it not?
Yep.
And then we got 6. What can we pair 6 with? How about 14? 6 and 14.
6 and 22.
Shout it out.
6 and 22.
I think that's it.
Yep, that's it for 6.
Okay, how about 9? 9 and 11?
Yep.
Okay. 9 and 13? 9 and 14, forget it. 9 and nope. 9 and 21, nope. How about 9 and 25? 9 so don't care, don't forget. 9 and 25?
-1001.
You buy it? That's it, right? 10.
9.
I'm sorry?
That's all for 9. Yep.
Yeah. 10. We can do 10 and 11. We can do 10 and 14. My stuff's running all together. That's why I like lined paper. Okay, 10 and 14, yes, no?
It was 10 and 26, don't care.
And then 10 and 26, you said?
Yep, and then that was also 10.
Okay, so we got 14 now, and we also have 26. What are we left with? 12? 12 and 13?
And 12 and 14.
12 and 14?
Yep.
Oh, this is a 0. And this is a 0. Okay. And 12, we can't do anything else, right?
Yeah, no, not 12. And then we go to 18.
18 and
19.
'18 and 19, right?
18 and 22.
Right, yeah. 18 and 22. Check.
Last one
18 and 26, right?
Yep, that's the very last one for index.
Okay. That's it for 2 compared with 3, right?
Yep.
Then we're left with 3 and 4, right?
Yeah.
Can we pair 11 with anything?
15.
Yeah.
11 and 15, what do you get?
You get
01-11? And that was 11 and 15.
And then you get 15.
We can't do 11 with anything else, right? Then we got 13 with 15.
Go.
And then we can do 011-1.
Yep.
And then
Can 13 go anywhere else? Doesn't look like it. How about 14?
14 and 15.
And
14 also goes with 30. That's it for 14.
so 15 and 30 there. Okay, so that's it for 14. 19?
23, don't care.
23, right?
10-11.
10-11?
Yep, that's what I got.
Okay.
That's all.
Can't do anything else with 19, right? 21 and 23, yes, no?
Yep.
Okay, so now we can mark 23 off and 21 and 23 off. 21 can't do anything else. Can 22 go with anything? How about 30?
23 first.
20, what?
22 and 23.
Oh, you're right. I missed it. So 22 and 23, yes, no?
And then 30.
1011 dash, right? Good catch. Did we do all this work yesterday? I don't remember.
Yeah, we did it all. Yeah.
Okay, 1-110.
And that's it for 22.
That's 22 and 30, right?
Yep, and
And
then the very
then
last one is 26 and 30.
yeah, we can't do anything with 25, but we can do 26 and right.
Yep, and then that's
11-10, right?
Mhm.
That's 26 dash and 30. Okay, that's the first pass, guys. Now, any questions on what we did so far? We did all this, right, yesterday? Now we're doing second pass, correct?
Yep.
Talk to me, guys. I don't want to erase the Carnot map, okay? Can I erase the index and midterm list and put the second pass here? Right here? Is that okay with you guys? Talk to me?
Yes.
Yes, no?
Yes.
Yes? I'm not hearing any strenuous objections, so therefore I'm going to do it. Okay. All right. Thanks a lot, Esteban. Thank you so much. Okay.
Thank you.
Your classmates, thank you. So do I. We're having fun. We're doing Boolean stuff. How can that not be fun? Don't answer that. Okay. Now, guys, we have to look at the second pass, right? That means we're going to try and compare we're going to try and pair the pairs we just found, correct? Right? Yes, no?
Yep. We
did some of this yesterday, right?
Yeah, we did about half of the list.
Okay. Did we do 2, 3, 10, and 11? Is that the first one?
Yep. So basically,
And
in this part, you're kind of just like looking with your eyes, like at your list, like you don't really have
yeah.
much.
Yeah, you can eliminate everything that where the dashes don't line up. That makes the job a whole lot easier.
Okay, I remember now.
And remember, you get 2 for the price of 1. I'm sorry, 4 for the price of 2, right? So 2 and 3, 10 and 11 get checked off, but also 2 and 3, 10 and 11, but also 2 and 10 combined with 3 and 11. That also gets checked off. Okay? Any questions on that? The next place where the dashes line up is 2 and 3 and 12 and 13. Can we combine those two?
So because it's more than a 1-bit difference.
Yeah, it's actually a 3-bit difference. So no, we cannot. Then we come up here. Don't forget to pair. Look up here. We had to bring the first pass up here. So can we pair 2 and 3 and 8 and 11? I see only a bit difference in the most significant bit, right? So yeah, we can combine them.
I don't have an 8 and 11 written.
I'm sorry, 18 and 19. I can't read my writing.
I was confused. Yeah,
18 and 19. Okay. So check off 2 and 3 is already checked. Check off 2 and 18. 2 and 18, check that off. Check off 18 and 19. And check off 3 and 19. Okay.
I think that's all for 2 and 3.
I'll buy that. How about 2 and 6? Can we do anything with that?
10 and 14.
2 and 6, we can't do anything here. We're looking for the middle bit being a dash. You said 10 and 14?
Yep.
2, 6, 10, 14. Is that what you're saying?
Yep.
Because I'm thinking I agree with it. Was it 2, 6, 10, 14, right? So we know the middle bit's a dash, and that's the 4's bit. We also know okay, so that's going to be the 16 bits off, least significant bits off, and that's a 1, right? Did I do that right? Yeah, I did that right. Okay, so 2, 6, and 2 and 10, that's already checked. And then we got 10 and 14. And we got 6 and 14 as well. Okay? What else can we combine 2 and 6 with, if anything?
18 and 22?
18 and 22. Can we combine 2 and 6 with 18 and 22? Yes, no? And I'm seeing 1 bit difference between the two pairs.
Yep.
So it's a dash 0, dash 1, 0, correct? Two, 6, 18, 22. Is that right? Two and 18, 2 and 6, they're done. 6 and 22, mark that off. And 18 and 22, got that. Okay, cool. Can we do anything else with 2 and 6? Talk to me, guys. I'm not seeing it.
No.
How about 2 and 10? We can combine it with 3 and 11, but we already got that, right?
Yeah.
Already got it. We can combine it with 6 and 14. We already got that, don't we?
Yeah.
Already got that. What else do we have?
2, 10, 18, 26.
Can we combine it here? 18 and 26?
Yep.
I'm thinking yes. I get a dash, dash, 0, 1, 0. Is that right?
Yes.
Yep. So I get a 2 and a 10 and an 18 and a 26. Don't care. Is that correct?
Correct.
2, 10, 2, 18, 10, 26, 18, 26. Well, they're dropping like flies, guys. But we got to keep on going. How about, I think that's it for 2 and 10, right? Pretty sure that's right. So 2 and 18. Can we combine it with 3 and 19? Yeah, we can, but we already got it. Can we combine 2 and 10 with 6 and 22? We already got it, don't we? 2, 6.
Yeah, we already got it.
Yep. 2 and 10 with 9 and 25. I'm thinking no. I'm sorry, 2 and 18 with 9 and 25. I'm still thinking no, though. 2 and 18 with 10 and 26. Don't we already have that?
Yeah, we have that.
What else? Nothing, right? We can't combine 2 and 18 with anything besides what we already found. How about 8 and 9, guys? Least significant bit has to be a dash, right? Can we go 8 and 9 with, where did I see it? 10 and 11?
Yep.
I'm going to vote a yes for that, right? 8, 9,
Yeah.
10, 11, yes? 8, 9, 10, 11. One of those was a don't care, right? 9.
9, yep.
And this is going to be most significant bits off. The 8's on, right?
Yep.
We have a dash in the least significant bit. What else do we have a dash in? In the 2's, right?
The 2, yeah. So it should be 0, 1, 0, dash, dash.
Yeah. So we got 8 and 9 in that. We also have 8 and 10. 8 and 9, 8 and 10. Then we have 9 and 11. and 10 and 11, which we already have. Okay, cool. What else can we combine 8 and 9 with, guys?
13.
12 and 13?
Yeah.
You buy that now? 8, yeah, we can do that, right? Don't we get 0, 1, dash, 0, dash? Is that right?
Yes, that's right.
I gotta sit down, guys. 0, 1, dash. Okay, what do we get? We get an 8 out of this. We get a 9, don't care out of this. We get a 12 and a 13. Is that correct, guys? Yes, no? So we check off the 8 and 12. We got that. Now we got 9 and 13. Check. And we got 12 and 13. Where's that? Yeah, 12 and 13 is a check, right? Okay. We got a lot of red checks over here, which is a good thing. Okay. What else can we do 8 and 9 with? Can we pair it with 18 and 19? The dashes line up there. Can we pair it?
No.
No, we cannot. So we go on to 8 and 10. Can we pair that with anything? We can pair it with 9 and 11, right?
Yeah.
8 and 10, 9 and 11, right? We already have it, right? We already have that one. Where else can we pair? Can we pair it down here? 8, 10, 12, 14, is that a pair?
Yeah, that's a pair.
Okay. What do I write?
0, 1, that's 1. 0, 1, that's 1. Yeah. That's 0. I forgot. Sorry.
Yeah, 0, 1,
0, 1,
0.
dash, dash, 0.
0. Yeah.
Mm-hmm.
And it's an 8 and a 10 and a 12 and a 14. Is that correct?
Yep.
Yep.
Okay. So we got 8 and 10 up there. We got 8 and 12 up there. We have 10 and 14 down here. That's already checked. And we have 12 and 14 down here. That's unchecked, but now it's checked. Okay, cool. Can we do 8 and 10 anywhere else? Now we can't, right?
Yeah.
We ran out of terms to pair. Yeah. How about 8 and 12? We need the middle bit to be a dash. Can we pair it with 9 and 13?
We already did that.
We already did that. Can we pair it with 10 and 14?
We did that already.
Isn't that the one we just did? How about 18 and 22? Can we pair 8 and 12 with 18? I'm sorry, 18 and 26. No, 18 and 22. This pair, 8 and 12 with 18 and 22. I'm not seeing it, guys. Nah, we can't pair them, right?
Yeah.
They differ in 20-bit positions. Okay, so we are done looking at index 1 pairs with index 2 pairs. Now we have to do 2s with 3s. Are you ready?
Yep.
Here we go, guys. 3 and 11 with 22 and 30, right? That's the only thing we can possibly do, right? We can't do that. They differ in every single bit,
Mm-hmm.
right? So we can't pair that with anything. How about 3 and 19? Can we pair 3 and 19 with most significant bits of dash with 14 and 30? No, not even close, right? We can't pair it with anything at all, right? 6 and 14. Can we pair that with 22 and 30?
Yes.
What do we get?
That's 110.
110? Is that what we said?
Yeah.
So we should get a 6 out of that, a 14 out of that, a 22 out of that, and a 30 out of that, right?
Yep.
And 614, that's already checked. 622, is that checked? Yes. 1430 is now checked. And 2230, right? That's checked. Okay.
Okay.
Can we pair 614 with anything else? I don't think so. No. Most significant bit, 622. Can we pair it with 14 and 30?
Already did it.
Already did it. Can we pair it with any? No. That's the only one that has the most significant bit being a dash. Next to least significant bit being a dash. 9 and 11. Can we pair it with 13 and 15?
Yep, we can.
What do I write?
0, 1, dash, dash, 1.
Okay. You're getting the hang of this, aren't you? You're doing really good. Did I do that right? 9, 11, 13, 15?
Yep.
9 and 11's already checked. 9 and 13's already checked. 11 and 15 and 13 and 15. Okay, cool. Where are we? 9 and 11.
See anything else?
Are there any?
11?
Can we do? Can we pair it with this guy?
No.
I get a no, and that's it, right? We can't pair with this, so we're done. Middle bit. Can we pair 9 and 13 with 11 and 15? Didn't we just do that one?
Yeah, we did it, yeah.
Yep. Any other? Can we pair 9 and 13 with 19 and 23?
No.
Now, can we pair 9 and 13 with 11 and 26, or 11, with 26 and 30?
No.
Nope. Okay, we're done. Most significant bit, 9 and 25, right? Can we pair 9 and 25 with 14 and 30?
Nope.
Not even close, right?
Nothing else for that one.
Nothing after that. How about least significant bit? Can we pair 10 and 11 with 14 and 15?
Yes.
What do I write?
10, 11, 14, 15. And then that's going to be 0, 1 dash 1 dash.
Oh my God, what is that?
Who was that?
Oh, it's me, Mohammed.
Oh, Mohammed, how you doing, buddy?
Good, how are you? Sorry for crashing the class.
Never apologize for crashing my classroom.
Okay.
Never. You know the rules. Crashers are welcome. Oh, yeah, I appreciate you chiming in. I really do. Good to hear your voice, my friend.
Thank you.
Yeah, we're doing a 5 variable Quine-McCluskey and Petrik's example. Don't you love it?
Yeah.
Brings back wonderful memories, doesn't it?
Oh,
Don't
yeah.
answer that. Okay, can we combine 9 and 11 with 22 and 23?
I mean 10, 11.
10, whatever I said, yeah. 10 and 11 with 22 and 23. I get a no.
No.
Okay, now we're looking at the middle bit again, right?
Mm-hmm.
Can we combine 10 and 14 with 11 and 15?
Yes.
Yep.
Yep.
But guess what?
0, 1 dash. Oh, we already did it.
Yep. Any other middle bits? Can we combine 10 and 14 with 19 and 23? I get a no.
No. 26 and 30? Oh, we can.
Yes, we can. I get a -1 -10. Is that right?
Yep.
Yes, no?
Yep.
And that's going to be a 10 and a 14. Yep.
26.
Keep on going.
And 30. 26 and
Very good.
don't care.
Thank you. 26. And then what do we got? 14 and 30, right? That's already checked. Okay, we already got that. We already got that guy. 10 and 14. Anything else? I don't think so.
Yeah, nothing.
Now we look at the most significant bit, right?
10, 26.
Can we combine 10 and 26 with 14 and 30?
We already did that.
We just did it.
Yep.
Already did it, right? And we don't have any most significant bit dashes, so we're done. How about least significant bit? 12 and 13. Can we combine it with 14 and 15?
Yep.
Yeah, we can. What do I write?
0, 1, 1, dash, dash.
12, 13, 14, 15. Yes, no? I think that's right. We already got 12 and 13 checked. We already got 12 and 14 checked. Do we have 13 and 15 are checked, so it's 14 and 15. Okay, cool. They're already checked off, so that's good. Where are we at? 12 and 13. Least significant bit. Can we combine it with anything else? Can we combine it with 22, 23?
No.
No, too much changes. Okay, how about 12 and 14? Next to least significant bit. Can we combine it with 13 and 15?
Yes.
Yes.
But it's already done.
Already done. What else can we combine it? 12 and 14 with 21 and 23. These two guys. I get a big fat no, we cannot combine them, right?
No,
and that's it, okay? That's it for that pair. So now we got to go to the top, right?
Yeah.
So 18 and 19, least significant bit. Can we pair it with anything? Least significant bit. We can't do 14 and 15. We really need to start looking at the higher midterms anyway, higher pairs anyway. Can we combine it with 22 and 23?
Yes.
And I get a 1, 0, dash, 1, dash. Is that right?
Yep.
And that's going to give us 18, 19, 26. Don't care.
22 and 23. Don't care.
Sorry. Yeah, you're right. 22 and 23. Don't care. My bad. And we're going to be able to check off. What are we going to be able to check off? 19 and 23 don't care. And 22 and 23 don't care. Yes, no? Right?
Who is speaking in my class?
I am.
Who's
Hi, Josh.
This isn't Josh. This is Professor Nolan.
Oh, very funny. Would you like to finish this, Professor Nolan?
Yeah, where are we at?
Right here. Okay.
Wait, I might need a Chipotle burrito first. I don't know if you can see your screen.
Okay, you go get your Chipotle burrito, and we'll finish it here while you're in line. Oh, you already got it. Okay.
Yeah.
So look at the middle bit. Can we compare 18 and 22 with 26 and 30?
Yep, we can.
Yes, we can.
What do we get?
1 dash dash 1 0.
One dash dash 1 0. I think everything's already checked off, right? Oh, what terms are they?
18, 22, 26, 30.
Good job. Very good job.
And then we're good. I think that's it.
You think that's it?
Yep.
Oh, so soon?
So soon.
What? Oh, that. Sorry, didn't realize you were still talking to them.
Yeah, I think we're done with index 2 pairings. I'm sorry, second pass pairings.
I'm gonna go and
Very
draw
good.
my burrito, guys.
Okay, have fun.
Message me on Discord if you need anything.
All right. Ready for the third pass? Yes, no?
So long.
Well, there's not going to be too many groups of 8, right? There's not.
Not too many.
Both dashes have to line up, guys. Okay? So, what we're going to do, what we have to do, is to combine this group with something down here. There has to be a dash in the least significant bit and a dash in the second to most significant bit. Okay? So, visually, just using your eyeballs, right? The easiest way to do it is probably to look for a dash in the least significant bit. So we're looking at this guy, and this guy, right? These 3. Do any of them have a dash in the next to most significant bit?
No.
Yes, but they don't line up
No.
with the last.
What's that?
Oh, I might have been looking at something else.
Okay. They don't. So this cannot be paired with anything. Okay? Does everybody understand that?
Yeah.
This can't be paired with anything. Okay? How about this guy? Dash in the most significant and least significant bits. Well, there's only 2 of them that have a dash in the most significant bit, and neither one also has a dash in the least significant bit. So that can't be paired with anything. How about this guy? 2 dashes, one in the middle, one to the left of it. Oh, we have a candidate, don't we?
Yeah.
I get a dash, 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 1, 0. Is that correct?
Yes. So 2, 6, 10, 14, 18, 22, 26, don't carry 30. That is a mouthful.
18, 22, 26, don't care, and 30. Is that what you said? I think it is. Okay, so what do we check off? Well, 2, 6, 10, 14, right? Check. I was trying to erase our previous work so we don't get confused. And that was paired with 18, 22, 26, 30. That guy is right here, so that's checked off. But there's more than that. 2, 6, 18, 22. That's a group of 4. And that's included in that grouping. So that's 2, 6, 18, 24. And if we choose that group of 4, that's paired with 10, 14, 26, and 30. Where's that at? 10, 14, 26, and 30. That's right here, guys. So that's checked. Lastly, you go every other one. So 2, 10, 18, 26, don't care. We checked that off as well. Isn't that this guy?
Yep.
Mm-hmm.
And that's paired with what? 6, 14, 22, and 30. That's right here, guys. Is that right? Yeah. Okay.
Mm-hmm.
Well, that eliminated quite a bit, didn't it?
Yeah.
Can we pair this guy with anything? Oh, it's already, we still have to check, just like we did before. We can pair it with this guy. We already got it, guys, right?
I found
2, 6, 18, 26, 18, 22. 2, 6, 18, 22, paired with 10, 14, 26, 30. That's in that group that we just found. We already got it.
I found one more.
Yeah, and one more. Two dashes in the most significant bit. The two most significant bits are dashes. Well, we can pair it with this guy, right?
Yes.
2, 10, 18, 26. Well, that's there. Paired with 6, 14, 22, 30. That's included in that as well, guys. Okay. What about this guy? Two least significant bits are dashes. 8, 9, 10, 11. Can we pair
12,
it here?
13, 14,
Yep.
15.
Yes, it's gonna be 0, 1, dash, dash, dash.
I am trying to reconcile. That's that. Okay. Okay, let's write it down. What do we got?
0, 1, dash, dash, dash.
Is that right?
Yep.
And this would be 8, 9, don't care, 10, and 11, paired with 12, 13, 14, and 15. Okay? You know what? I know what's missing. I think. Yeah. No one caught it. I certainly missed it. We're missing midterm 6, guys, on the Karna map.
Uh-oh.
We got 2 and 3. Those are these two guys right here. We're missing midterm 6, which is right here. We've got 8, 9, 10, 11, 12, 13, 14, 15. That's this group of 8 right here. It kept bugging me when we found two groups of 8 why I couldn't find them in the Karna map. Well, I forgot a midterm. That's why. Okay.
If I'm not wrong, we're done with the third pass. I don't see anything else.
I think we are, but we have to check things off and so we don't include anything we shouldn't. So that last pairing we found was 8, 9, 10, 11, and it was paired with 12, 13, 14, 15, right?
Yeah.
But it also 8, 9, 12, 13, which is right here, that was paired with 8, 9, 12. That was paired with 10, 11, 14, 15, right?
Yep.
That's right here. That's checked as well. What else can we check off? Every other one, right, guys? 8, 10, 12, 14. That's right here. Paired with what? 9,
11,
11.
13, 15.
There you go. And that is right here. Okay?
Yeah.
For the sake of completeness, we're done with 8, 9, 10, 11. We would look here. So middle bit and least significant bit, where are they dashes? Right here. So we can combine these. Oh, wait, we already did. That's the one we just did. Can't do anything. We can look here. Can we combine 8, 9, 12, and 13 with this guy?
No.
Can we combine this term with this term? Do you see that we can't? Sure looks tempting, but the most significant two bits are different. So we can't. How about this guy? Can we pair it with anything? We can pair it with this guy, right? We can pair this guy with this guy, these two. Oh, wait, we already got that, don't we? 0, yeah, we already got that. Yep. Okay, so, ladies and gentlemen, we have, by the way, can we do a fourth pass? Can we, actually we can't because these both are index 1. We don't have any index 0. We don't have any index 2. So no, we can't pair anything. Okay. Now, we have to number these, right? So we can do Patrick. Sorry. What do you want to name them?
Let's do it at alphabet.
A what?
Like alphabet A, B, C, D.
You want to do A, B, C, D?
Yeah.
Oh, that's so boring, but okay, fine.
We'll do a cat head and a dog head.
Cat and dog? Here. We'll do A, B, C, D. What stands out? Does the teal? I don't know if I have a teal one anymore. How about a brown? Does the brown stand out from the blue? Can you tell the difference between brown and blue?
Oh yeah, slightly.
A little, yeah.
Okay. All right. So you want to call this one A?
Sure.
Sure.
Where's B?
So the ones
B's
that
over
you
here,
don't
right?
use are your letters?
The ones that are not checked, they are prime implicants.
I think B is gonna be 101-1.
It is. Don't forget to go back and look at the first pass and even the individual midterms. Make sure they are all checked. If they're not grouped with anything. Therefore, they are prime implicants, okay?
Okay.
You have to make sure you go back and check. How about in the second pass? Is anything not checked?
Yeah, the first two.
So I assume you want a C and a D there?
Yeah.
A C and a D, right?
Yeah.
These are all checked, right?
Yeah.
These are all checked. That one's checked. What about this guy?
Is that E?
E?
Yeah.
Okay. And that's checked. Okay. So we're done with the second pass. What about these two? F and G, yes, no?
Yep.
Okay. Now, everybody, you should be able to match anything we did with Quine-McCluskey to the equivalent grouping in the Karnaugh map. Okay? We found all the pairs, right? So we found this pair, that pair, that pair, that pair, this pair, that pair, and so on, right? That's why there's so many of them. Okay? We found all the groups of 4. We found this group of 4. We found this group of 4. We found this group of 4. We found this guy. We found this guy. We found these two paired with these two. We found this one. Okay, we found all the groups of 4. We combined a lot of them into groups of 8. Where are the groups of 8? Well, this is definitely one of them, is it not? Right? The bottom 2 rows for V equals 0. Well, that's minterms 8 through minterm 15. Okay, and that's group number G, right? And we also have a group of 8 right here. This rightmost column for V equals 0 paired with the rightmost column for V equal 1. That's another group of 8. And that would be group number F that we found using Quine-McCluskey, okay? You have to be able to you need to make sure that you can do that, okay? So 1-to-1 corresponds between Quine-McCluskey and the groupings in the Karnaugh map, all right? Now, ready for Petrik's?
Yep. I'm glad you did this because I didn't know that we had to find the prime implicant.
Yes, you have to find the prime implicants. Absolutely. That's what Quine-McCluskey's all about.
I wasn't checking because I was like, well, I'm just like following along with my fingers, so I wasn't like checking things off. I didn't.
Oh, yeah. It's if you get a big one like this, it's real easy to get screwed up, isn't it?
Yeah,
real
I didn't
easy.
realize why it was so important to check things off.
Yeah, you got to check them off, and you got to check off everything, because otherwise you're going to have you know, if you forgot this check mark, you're going to call this a prime implicant. Well, it's not a prime implicant because it's included in group G.
Yeah, I'm really glad we did this because I would have been sitting there looking stupid for a couple hours.
Okay, are you ready for Petrix, guys?
Yes.
What can I erase?
Everything, I got it all.
Okay, can somebody take a picture and post it?
Sure.
And what I do is I will erase this up here. Okay, but I will replace it with the prime implicants and what minterms they comprise. Okay, so I'm going to erase. Do we have it posted in the chat?
Yep, it's uploading.
It's there?
Just give it 1 second. Make sure it went through. Yep.
Okay, I see it. Okay, so I'm going to erase this, okay? From here down to here, okay? So what's group number A, guys? Help me out.
I'm working on that myself. It is 9 note care and 25.
And it's represented by a -1001. Yes, no? Correct? Got that right here.
Yep, you're good. -1001.
Okay, so that's a W. Guess what I got, guys? No applause, no nothing. Really? I'm proud of myself for that.
What did you get? I wasn't looking at I was looking at my notebook.
I said, guess what I have?
Oh, yeah, that was important.
Is that not impressive or what?
Oh yeah, you should bring them to the lecture for sure.
Oh, I'm working on it. Yeah, I'm working on it. Okay, I don't use the orange because you guys can't see it. Yellow, forget it. Orange, do I have purple? I like the teal. That seems to come through really well. Maybe it's because I'm partial to the Marlins. I don't know. So I can get rid of the orange because you guys can't see it. I'm running out of room for my markers. Okay. Okay, and then we do that. How's the burrito, Josh? Okay. So this is a W.
Good.
Evidently. Yes, no, guys? That's the Boolean representation for group number A.
Okay, let's see.
What's B?
That would be a V W naught X V.
That's exactly what I get. Where are they on the Carnot map?
That I'm still working on.
Well, where's 9? Well, 9, V is clearly 0 because it's in the range 0 to 15, right? So minterm 9 on this Carnot map is 0 to 3, 4 to 7. 8, 9. This is 9 right here, guys. Okay? And is paired with minterm 25. Well, minterm 25 is down here, isn't it? Down here. And 25 is right here, guys. So that is the pairing of this don't care with the minterm 25 on the plane below it, okay? That's these two guys right there. And we said we're going to have to do that, if you recall. Where's this grouping? 21 and 23 don't care. Where's that at? Help her out, guys. Everybody should know this. We know it's in this plane right here, don't we? Vehicle
This
1.
is where I was kind of asking before. Like, I don't know if Carl Maps kind of skipped me a little, but I have trouble
Okay,
finding.
all right. Okay, let's do it then, right? Let's do it. We know that this is the grouping, right? 101-1, right? Well, that means vehicle 1, so we're in the bottom plane. We know that, right? Right?
Okay. Yeah.
Then we know that W is a 0, yes, no? Where is W0 in the bottom plane? Isn't that these two top rows here?
Okay.
0 is a W, right?
Yep, I see that.
Okay. We also know that the X is a 1.
Oh, it's in that row. Yeah, I see.
Which row? Top row or
that one? Yeah.
This guy, right? Right? Because W is off, X is on, right? Well, where's the grouping?
One goes.
Z is on, right?
Yep.
Right? Well, where is 0 on in this row? Z is on for the middle two columns, right? There and there. Z is on here. Z is on in the next column. Well, it's not only in this row, but it's in these two. It's right there.
So that's their pair?
That's the pair. Yep.
Okay, I see that.
All right. And that's how you do it. You just say, okay, X is on, Z is off, so you go on the Carnot map and figure out where that's the case. Okay. Now, we got A, we got B, so I can erase this, right? I can also erase this group of 4, right?
Yeah.
Because all that information is already captured. So what's group number C?
2, 3, 10, 11.
2, 3, 10, 11. Very good. And that's represented by 0, dash, 0, 1, dash. And what do you get out of this? What's the Boolean expression for group C?
V naught, Y naught, X.
Is this V naught, Y, X naught?
V naught. I think it's V naught, Y naught, X.
D is off, so it's V naught. W disappears, it's a dash. X is off, right?
Yep.
X naught. Y is on, right there. Z goes away because it's a dash.
Okay.
And want to know where on the Carnot map we're looking? 2 and 3 are right here, are they not?
Yeah.
Right? Where's 10 and 11? Isn't it right here?
Oh, I see.
It's the wraparound in the top plane. Okay?
Okay.
All right. Where's D? What's D?
2, 3, 18, 19.
Okay. And what do we get out of that? A dash?
0, 0, 1 dash.
Okay. So there's no V.
It'll be not X, not Y.
I will totally buy that. And where is it in the kernel map? Well, we know where 2 and 3 is, right? Where's 18, 19? Well, 18 and 19 are in the bottom kernel map. It's these two. So it's this group, this pair, combined with this pair to make a group of 4 that spans the 2 planes, okay? What's number E? It's this guy, isn't it?
Yep.
18, 19,
So it's
22, 23, don't care.
okay. 18 and 19 are here. So that's 16, 17, 18, 19, 20, 21, 22 is here. 23 is here. So it's this group of 4 right here. Okay, that's group number E. So it's a 1. What is it, a 1?
0 dash 1, 0.
Isn't it 1, 0?
Dash
Isn't this a dash in the
1
least
dash.
significant
Yeah,
bit?
sorry.
Yeah. What's the Boolean representation?
It's V, W, not Y.
Okay. And then we have F and G at the bottom, right? Right, guys?
Yep.
Mm-hmm.
Okay. So we've captured all of our Quine-McCluskey work right here. Can I erase this so we can do Patrick's?
Yes.
Going once, going twice. Okay, let's do Patrick's. I hope we have enough room. This is going to be tough. Maybe we should do Patrick's on its side. I don't know. That'd be confusing, I think. Let's try dark blue, see what that looks like. So, we have, what's the midterms, guys? 2, 3, what else?
Mm-hmm.
2, 3, right? 2, 3, 6, 8. Then we got 9, right?
Mm-hmm.
We don't put 9 up here. Why not?
Just don't care.
It's the don't care. Don't cares get omitted in Petrix, the application of Petrix.
Yep.
We're going to run out of room.
14, 15.
We are going to run out of room. Shoot. Should have written them over here. Let me do that real quick. All right. What's A?
9, 25.
What's B? Combines 21 and 23.
Mm-hmm.
C combines 2, 3, 10, and 11. What's D?
2,
2,
3,
3,
18,
18, 19. Thank you. What's E?
18, 19, 22, 23. No. Don't care.
And what's F? F is down here.
2, 6, 10, 14, 18, 22, 26. Don't care. 30.
And lastly, G is
8, 9, don't care. 10, 11, 12, 13, 14, 15.
Take a what?
Very good. Thank you. That's going to make, we just don't have the Boolean representations, but you have those in your notes, do you not?
Yeah.
Back here. Okay, 15, then 18, then 19, 21, 22, skip 23, 25, and 30. Yes, no?
Yep.
Okay. So I have to erase all of this, unfortunately. So, all right. Okay, let's do this. Let's get a new marker. Okay, so we got A, B, C, D, E, F, and G. Okay, if I had enough room, which I don't, I would put the min terms that are associated with each one of these. Okay, because that makes filling out the chart a whole lot easier. I hope that's obvious to you. This is why doing this on graph paper is like almost a requirement. For the opportunity, you will have tables that I give you. They will be provided for you. Okay. So you don't have to spend a lot of time creating tables. They will
This
be.
would be something that we print out, probably.
Yeah.
Okay.
Yes. Okay. Now, A consists of 9, don't care, which is not even here, obviously, and 25. Yes, no? Okay. What's B? 21, 23, right? 23 is the don't care. I forgot to put it in here. Okay. Yeah. What's C? What does C include, guys?
2, 3, 10, 11.
How many? 2, 3.
3, 10, 11.
Thank you. What's D include?
2, 3, 18, 19.
Okay. And what does E include?
18, 19, 22.
23 is the don't care.
Yeah.
Then we got 2, 6, right? What else?
10, 14.
Keep on going.
18, 22, 30.
Okay. And what's F?
8, 10, 11, 12, 13, 14, 15.
It's really easy when they go right in a row like that, isn't it? Well, easier. Okay, guys. So, couple ways to do this. Couple ways to simplify this, okay? We can do it with the, actually, it wouldn't be horrible, I don't think. We can realize the expression if we include minterm 2. Well, that's a C ORed with D, right? Oh, ORed with F, right? Right, guys?
Yep.
And we got to and that with C ORed with D, right? Yes, no?
Yeah. Yes.
And then we and that with F. And then we AND that with G. And then we AND that with C ORed with F ORed with G, right?
Yeah.
Right? And then we got a C ORed with G, yes now?
All right, I'm just a little confused as to what now. Where is this coming from?
Okay. In order to realize the function, we have to be able to grab minterm 2. That has to be included. Well, how do we do that? How do we include minterm 2? Well, we can include it if we have prime or we have prime implicate D, or we have prime implicate F, because those all include minterm 2. Okay? And we have to include minterm 3. So how do we do that? Well, we would need group C, implicate C, or implicate D, one or the other, or both, right? If we included either one or both, we would include minterm 3. And we have to include minterm 6. How do we do that? Well, 6 is only included in group F. Now, do you see it?
Yeah.
You weren't very convincing, Kylie.
I was like looking. So basically, throughout the whole map, we're just gonna. So then it would be like F, and then it would be G, and then it would be C plus F. C ORed with F, ORed with G, and ANDed with C, ORed with G, and then it would be ANDed
Keep on
with
going. Keep on going. Don't stop now. C ORed with G, right?
And
Okay.
then, wait,
Then what?
And then it would be just G, and ANDed with G, and then ANDed with another G, and then it would be ANDed with an F, ORed with G, and then another G, ANDed with, and then ANDed with a D, ORed with an E, ORed with an F, ANDed with a D, ORed with an E, ANDed with a E, ORed with an F, and then ANDed with an...
I just got B on that. It's not part of F. Minterm 21.
Look at the top part. I didn't see the top part.
Okay. Yeah, B. Minterm 21 is only included in B.
Yeah, because I forgot to write the top part.
Okay.
So yeah, you got the B, and then it would be ANDed with an E, ORed with an S. And then it would be ANDed with an A. And then it would be ANDed with an F.
With F, right?
Yep.
Okay. This looks pretty daunting, doesn't it, guys? It's really not. Any term that includes F can go away because F is all by its lonesome here. Okay? So this disappears, that disappears, that disappears, gone, gone, and we only need one F, we don't need two. Okay? Well, that got rid of about half of the nasty ones, right? Oh, we can get rid of this one.
Yeah.
We can get rid of that one, right?
Yeah.
And what did you say, Kylie?
We also get rid of anything with a G in it.
With a what?
With a G.
A D?
G. Like
G.
Giraffe.
Giraffe.
Yeah.
Yeah, because it's right here, right? So what can we get rid of?
On the other G. And C plus
All these
G.
guys, right? And
Yep.
and what'd you say? This guy, right?
Yeah. Yeah.
Okay. See, it's really not that bad, is it? What are we left with? We got an F,
There's one
we
more
got a
G you had to
G.
get rid of.
Oh, we can get rid of this G, can't we? We only need one G. We don't need two of them, right?
Yep.
So we need F, we need G. A, B, F, and G. Those we need no matter what, okay? What else do we need?
C plus D.
C board with D.
Yeah, C or with D. Sorry.
And then D
C
or
board with D.
E.
And then what?
D or with E.
Okay. We can't do anything about these guys, right?
Yeah.
Yep. Now, guys, if you want to do a sanity check, okay, let me show you a graphical way of performing Petrix. Okay. It'd be hard
This
to program.
is a bedtime story
but,
and a
if
rise
you're
and shine.
doing it like we're doing it,
A
you
good
can
first
use this.
impression.
Okay.
And a true story.
We know that we need group A, right? Because A is the only thing that includes 25.
This is
right?
everything and nothing at all.
Okay.
This is a
So we
selfie
got midterm
and an
25
epic
covered.
night.
Okay. We know we need group B, right? Right?
Mm-hmm.
Because this is the only thing that has 21. Okay, so we need A, we need B. What else can we pick on? Oh, we know we need group number F, right?
Yeah.
It's the only thing that has 30 in it, right?
Yeah.
So we need this guy, and that's gonna include is whatever this guy is, whatever this guy is. Where else? Oh, this guy, right? And that one, right? So by having A, B, and F, we got all these midterms handled. What else do we know we need?
C plus C or D.
Well, we need G, don't we?
Yeah, with G.
We need G because it is the only implicant that includes midterm 8. So we need G as well. And G is going to handle this guy, this guy, this guy, this guy, and this guy, right?
Yeah.
So the only midterms that we have to worry about are midterm 3, which we can grab with C or D, doesn't matter, and midterm 19 is D or with E, right?
Okay.
Right?
Yep.
Well, that's how we got this expression. Now, graphically, if you take a step back and look, what happens if we include D? Well, that's going to grab midterm 3. Is it going to grab this guy too? Yes. Do you see that? So if we only grabbed D along with these others, the other 4, we would be able to realize the entire function. Okay?
Mm-hmm.
What if we didn't want to do that? Well, we would need C, right? Group C. So we had midterm 3 included, but we would also need, along with C, we would also need group number E, correct?
Yeah.
So that midterm 19 could join the party. All right? So that's what this expression down here is telling us. Okay? If we distribute the 2 parens out, we would have A, B, F, G, D. Work it out on your paper to prove it. or A, B, F, G, C, E. Those are the two forms of Petrix. Petrix gives us these two forms of the expression. Okay?
But they're both equally correct.
They both completely, they're both irredundant, right? We know that they don't have any redundancies because we use Petrix. Irredundant expressions using prime implicants. We know all of these are prime implicants from our Quine-McCluskey work. Okay?
Mm-hmm.
So, we're not done. If the problem says, and they always do, if they say find all the find the Boolean, the most simplified the Boolean expressions containing irredundant prime implicants. Okay, these are not Boolean expressions, right?
Yep.
These just tell us which prime implicants to use in the Boolean expressions. Okay, so this expression right here, what's the Boolean expression for that? What's the Boolean expression for group A? I erased it, but you should have it in your notes.
W X naught Y naught Z.
W, X naught, Y naught, Z?
Yeah.
Is that what you said? Okay. That's group A. What's group B?
V W naught X Z.
Okay. What's F?
Y Z naught.
What's G?
V naught W.
And what's D?
W naught X naught Y.
What's the cost of this expression? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? How many AND gates do we need? I get 5.
Yeah, 5.
I get 21. Did I do that right?
Mm.
Did I do that right?
Yep.
I think I did. What's the other form of the expression? Well, we need A, right?
Yeah.
W, X naught, Y naught, Z. We need B, V, W naught, X, Z. Ordered with. We need F and G. Those are Y, Z naught. Ordered with V naught, W, right?
Yep.
Then we need C. What's the Boolean expression for group C? V naught.
It's not Y.
V naught. It has to have 3 variables. The Z is going to disappear. The 2 bits on. So isn't that a Y instead of Y naught?
Yeah. That's V naught X naught Y.
V naught X naught Y.
Yeah.
I'll buy it. Ordered with what's E? V. Let's see, the 4-bit changes. So it's going to be V W naught.
Y.
Hold on. What's the cost of this expression?
$18.
Is that how many literals?
18.
I'll buy it. Plus 6, right?
Yeah.
Plus 1, 25. These are two different forms, two different expressions. They are both as simplified as they can possibly be. Okay? They will completely and totally give us F without a problem. However, the cost difference is actually pretty substantial. Okay? I hope you understand and can see that if the only reason, well, one of the good reasons that you might implement this form of the expression instead of this one is maybe your circuit design uses some of these products in other areas of the circuit. So if you generate, say, this product and this product for this expression, if they're needed in other areas of the circuit, they don't add cost to that other area of the circuit. Does that make sense? It's possible that they're needed somewhere else. So it would make sense to use this form of the expression in that case. If that's not the case, then you'd be crazy to do this form. You should do this one. You always want to go with the lower cost unless you have a reason not to.
So just to clarify, the top one was a cost of 21, was the first equation, and then the
This
bottom
guy.
one was,
This one?
that second one is that one, okay. So then, would you be able to go over again how you got that simplified version of that? How you looked at the Tetrix and got that?
These?
No, how you got the ABFGD plus ABFGCE?
This guy.
Yeah, like how you got that whole simplified version instead of just using ABFG ANDed with C, ORed with D, ANDed with D, ORed with E.
Are you saying you don't know how we got from here to here?
Yes.
Okay, that's easy. Okay. Obviously, this goes along for the ride, right?
Mm-hmm.
Right? And it's ANDed with C, ORed with D, ANDed with D, ORed with E, right? So distribute this out. This is going to go to C, ANDed with D, right?
Mm-hmm.
ORed with C, ANDed with E, right?
Yep.
ORed with D, ANDed with D. Well, that's going to go to D, right?
Mm-hmm.
ORed with D, ANDed with E. Do you see that?
Yes.
Well, D ANDed with D goes to D, right?
Mm-hmm.
Well, what's D ORed with DE?
Wouldn't that be E? Or no, it's DE.
No,
Is it D?
no. It's D, right?
Wait.
Right?
Oh, okay.
Do you remember that, Kylie?
Yeah, I gotta refresh my Boolean algebra.
This goes to one ORed with anything goes to 1.
Mm-hmm.
So it just equals D, right?
Yeah, and then that becomes a D plus D, right?
So this goes away, right?
Mm-hmm.
So now we have CD ORed with CE ORed with D. Well, this has a D in it as well.
And that's
Okay.
just
So what's CD ORed with D?
C.
Careful. It's the same form as this, right? Do you see that? Right?
Yeah.
This would go to D.
Yeah, that's what I said.
I'm sorry. I thought you said C. I'm sorry.
No, yeah, okay.
I'm really sorry.
I was
I
really
thought you said
confused for a minute.
Okay,
Yeah,
so
yeah,
we're
I
not
get it.
confused anymore, are we?
No.
Right? Okay, so these two things, when you and them together and all that distribute stuff, it just simply goes to D or with CE.
And then you
These four
the
ANDed with this quantity, which is where we got ABFG, that's the part that goes along for the ride, ANDed with D,
mhm.
ORed with the part that goes along for the ride, ANDed with CE. That's how we got that.
And then you just I get it.
And then you just substitute the Boolean expressions and for each one of these implicants and OR them together. Okay? You let it simmer for 15 minutes and then it's ready to go. Oh, wait a minute. That's cooking. Never mind. Did I answer your question, Kylie?
Yes. Yeah, I just need to get better at Boolean algebra.
I do too. I had the same problem.
So then I'm having a little trouble. I get completely everything you're doing. I'm just having a little trouble reading that bottom. I got the cost 21 one, but the one where it says, would you be able to read that off for me?
I most certainly can. You have this, do you not? This expression?
Mm-hmm.
Do you have this expression?
Oh, I can't really see what you're pointing to.
Okay, all right. The second form, right? The form of these implicants is W X naught Y Z, ORed with V W naught X Z, ORed with Y Z naught, ORed with V naught W, ORed with V naught X naught Y naught, ORed with V W naught Y.
W not Y. Okay, I got it. And the cost is 26.
25.
25, okay.
Yeah. There's 18 literals. You should count 18 literals. Okay. And again, a literal is just the number of variables or the complements of variables. You just count them up, ignoring all the signs. And then we need 6 AND gates because we have 6 implicants. And we have 6 implicants of at least 2 variables. And we have one overall, what it would be a 6 input OR gate that still has a cost of 1, even though it's 6 input.
Okay. Yep, I think I got everything now.
Cool. Are there any other review questions, guys?
Excuse me, I just have a little question. I'm not sure why we find first part and second pass. Are there any way we can check if we mixing something?
Yeah. In the second pass, which I erased, in the second pass, what you can do, you should be able to map your second pass pairings. You should be able to map them all the way back to the original min terms. And you do that through the first pass pairings, right?
Yeah.
So like the group 2, 3, for example, D equals 2, 3, 18, 19, right? So you should have a pairing of 2 and 3. You should have a pairing of 2 and 18. you should have a pairing of 3 and 19, and you should have a pairing of 18 and 19. Okay? So one of the common things that, one of the common mistakes that's made, including myself, okay, I'm not excluding myself from any of this. I might forget this in the first pass. I might not see it. I might have seen it and got distracted and completely ignored it or something similar to that, right? Well, when we formed this, because we could still form this group by combining 2 and 3 with 18 and 19, right?
Yeah.
So this pairing still provides this group. But in the forming of that group, it also combines the pair of 2 and 18 with 3 and 19. So then you look back to check off 3 and 19 and you're going, oh no, I forgot 3 and 19. I missed it. Well, now I didn't miss it. Okay. So in the process of checking stuff off, that's a good way to go back in your first pass and make sure you didn't miss anything. Okay. Did I answer your question?
Oh, sorry.
Yeah, kind of. So if we choose to use the Patrick method, do we have to draw the Kano map?
No, absolutely not. No, I was just, the only reason I did the Carno map at all was to get you guys to see that Klein, McCluskey, and Petrix does the Carno map stuff for you. And it actually goes one step further. It finds all of the forms of the simplified Boolean expression, not just the one that you happen to notice.
Okay. Oh, and by the way, I'm a little confused how to group in a Kano map. Can you briefly summarize how we group in a Kano map?
Absolutely. How about if we outline where all these groups are?
Yeah.
Sound good?
Sound good.
Okay. So 9 and 25, right? Well, timeout. If you're doing a Karna map, you wouldn't exactly know this information. Never mind. So we would start with this, right? We would start with this, okay? And we want to find the simplest form, right?
Yep.
Right? I mean, that's the goal, right? So first thing you do is you check for as many large groups as possible. Actually, I take that back. I'm out. The first thing that you should do, first thing that I do, is I try to look for stragglers. I try to look for min terms that are all by their lonesome, okay? Or there's only one other min term that they can be paired with, okay? Well, I hope it's obvious. None of these terms here in these two rows, none of these min terms fit that, right? They all can be grouped multiple ways.
Yep.
Okay. This guy right here, well, he's a little more isolated, but he can still be grouped with this guy or with this guy. And if you look at the plane where vehicles one, he can be grouped down here. So he can be grouped multiple ways. Same is true of this guy, right?
Yeah.
This guy can be grouped with this one, or it can be grouped with that one down there. So nothing in this plane really is standing out as somebody sitting there out there all by his lonesome. If you come down here though, look at this guy. This guy doesn't have any neighbors to either side. It doesn't have the midterm above it. It doesn't have the wraparound, okay? Its only neighbor is in the above plane, okay? That tells us that this grouping okay, this guy right here, that grouping is a grouping in the kernel map, and it's going to be in the final solution because there's no other way to grab this minterm. No other way to do it. Is there anything else that stands out as being okay? We gotta have this as a group too. Well, these guys all belong to, they have neighbors, right? This guy is a neighbor, even the don't care. It can be combined with either side or above it. What about this guy? It can't be combined with anything above it because this minterm right here, I think it's minterm 21. This minterm cannot be paired with minterm 5 because 5 doesn't exist. It can only be paired with his next door neighbor. So that group has to exist as well. Okay. So now that we took care of all the ones that are kind of like all by their lonesome, now we start looking for the bigger groups. Okay. Are there any groups of 16? Well, I'm not seeing any. And in fact, there's not.
Yeah.
Are there any groups of 8?
Yeah.
Where?
The 2 line bottom in the
this guy, right?
table. Yeah.
Okay. Any others?
Yeah. There's one more on the
Where do you see it, Kylie?
right side. If you group those 4, and then the bottom group.
Yes, no?
The
Okay.
Right? These guys with these guys. Okay? So now, looking at the cardinal map, this guy's covered, right? This guy's included. This guy is included. He's joined the party as well. These 4 and these 4, including if we include the don't care, those guys are all invited to the party. This group of 8 is also a member of a group already. So what are we left with? Looking at the cardinal map, this guy is not a member of a group yet, nor is this guy, right?
Can't those be grouped because they're adjacent?
Shout it out.
Those can be grouped because they're adjacent?
They can be. Can they be grouped they can be grouped in a group of 2, yes, no?
Yeah.
Yes.
They can be. Can they be grouped in a larger grouping than 2? Can they be grouped in a group of 4?
Oh yeah, with the 2, with the one next to it.
Right? This guy, these 2. Actually, this guy can be grouped. He can be grouped with a group of 4 right here, can he? Right? Mm-hmm. We have this group. That's a group of 4. That'll handle this one, but it won't handle this one, right? How do we include this guy?
You're standing in front of it.
How do we include this guy?
You group those 2 on the outside.
Could we do this? You always look for groups of 4. If you have a group of 2, you have to see if you really need to look and see, okay, I got a group of 2 here. Can I make it into a group of 4, right? Okay. Since we're dealing with these 2 guys, do you see, ladies and gentlemen, that what color should I use? Teal. Do I have a teal? I think this is teal. We also have this guy grouped with this guy, right? That's also a group of 4. Okay.
Oh, okay.
So we got a lot of groups here. And I'm telling you right now, we probably have redundancies. In fact, I know we do. Do you see, ladies and gentlemen, that if we have these guys and these guys grouped together, and this grouping down here, we don't need the group in teal. Do you see that?
I'm sorry, can you repeat?
Yeah, absolutely. If we use this grouping right here, okay? If we use that grouping, it's grouped with this guy, right? It's the wraparound. These two guys with these two guys. If we use that grouping, and let's see, that would include this guy, and we include this grouping down here, right? Then we don't need the group in teal. This guy's already included in the group of 4 here. This min term's already included in the wraparound grouping here. So we wouldn't need the group in teal, because if we took the group in teal out, we would still have all of the min terms as part of a group. Do you see that?
Yes.
So in that case, the group in teal would be redundant. Does everyone see that?
Yes.
Yes, no? Talk to me.
I see it.
Okay. If you're keeping score at home, I hope you see that this wraparound group right here, that's group number C. Okay. It's min terms 2 and 3 grouped with min terms 10 and 11. That is group number C. Okay. All right. What's this grouping here in the upper right-hand corner in the bottom plane? Well, it's min terms 16, 17, 18, and 19 paired with 20, 21, 22, and 23. Isn't this group number E?
Yeah.
Do you see that?
Okay.
You buy that?
Yeah.
And lastly, something else we can do. What's the group in teal? If it's truly minimized, largest group possible, it should be here. Well, it's min terms 2 and 3 combined with min terms 18 and 19. Isn't that D?
Yeah.
2 and 3 combined with 18 and 19. Okay, now, are there any questions on that? Not hearing anything? Okay. I can't, whoever was talking, I didn't get any of that.
Sorry. Do you think you'll make us do 5 variable K-map on the exam?
Wait a minute. I don't like the word make you do.
Sorry,
the phrase. I'm not going to force you to do anything. You will see a 5-variable Boolean expression that you will perform Quine-McCluskey and Petrix on for the 24-hour take-home thing. Okay.
No, that makes you feel better to not say make.
No, this is way too much work for like a 3-hour thing where you're doing binary arithmetic and number conversions and simple kernel maps. They still take time, right? You'll see a 4-variable.
You're not gonna have us fill it out, but you'll put it there for help.
You'll have a 4-variable Quine-McCluskey, definitely.
Okay.
But 4 variables a lot easier than this, right?
Yeah, definitely.
Okay. So, Kylie, do you see where that the kernel map is giving us groups C, D, and E, and they're the same thing we found using Quine-McCluskey. Using Quine-McCluskey, right?
Mm-hmm.
Right.
Yeah.
So, and we said down here that if we include D, we get this, right?
Yep.
If we include D, along with the ones that we have to have no matter what, right? So if we include D, we don't need C or E. Is that true according to the kernel map? Remember, we didn't form these groups of 4 until we had to group these 2 min terms, right? We needed to group these 2. So if we group them in D, they are both included in D. So we don't need C. That would be redundant. We also don't need E because it would be redundant as well.
Okay.
Okay? Does everybody see that? If we have D, we don't need C, we don't need E. Okay? That's what this expression here is telling us. That's what this is telling us from our Petrix solution. Okay? If we don't have D, we can still realize the Boolean function if we have C, which is the wraparound. That's going to include minterm 3. And we have group E, which is going to include minterm 19. Okay? So if we don't have D, we would need to include C as well as E. And that's what this form of Petrix tells us. This form right here. Okay? So the bottom line, and I hope you see this, I really, really do. The bottom line is that the kernel map solution, if you look for all possible solutions, the kernel map and Quine-McCluskey and Petrix, they are all telling us the same thing. They're just 2 different tools to accomplish our goal. Does that make sense?
Yes.
I feel like it's such a profound statement. I keep waiting for like this music, this I don't know what kind of music, but this kind of music to play like at the end of a movie. Anyway, that's just me. You ever notice how they don't make any movies about engineers?
This wasn't a very fun movie to watch.
What about that?
That hurt. That hurt.
What was the movie about the women in NASA? That was an engineer.
Oh, yes, it was. It was. Yeah.
Hidden Figures.
Hidden Figures, yeah. Did that start with like Grace Hopper? I can't remember. There are quite a few women engineers at NASA, and most of them are really, really, really good. So, yes, I could definitely say that. But okay, other than that, there's not too many movies made about engineers, you know.
There's documentaries.
I can't hear. I didn't understand that. Go again.
Documentaries.
Well, I don't. Maybe it's that we don't blow enough stuff up. I don't know.
October Sky was really good. Did you ever see that one?
What did I see?
October Sky.
I've heard the movie. That was. God, what was that about? Was that about the Russian? Was that about the Russian space program?
Who was it? Homer Hickam was the guy. And yeah, they made like rockets in their backyard, these boys, and they went to state and stuff.
Yeah. That was in the infancy, right? Did that have Robert Goddard?
The name sounds familiar. I don't remember.
Yeah, Robert
He's
Goddard.
like the dad with black lung or something like that.
I don't know. Robert Goddard is considered the father of rocketry.
Deepwater Horizon. That was more about an engineering failure.
Was that a documentary about Deepwater Horizon?
No. Well, it was more an actual theatrical movie about it.
Oh. Okay. Well, still, there's not too many movies about engineers. It's very sad. Very sad.
Make one.
Well, I'm not a movie. I'm not creative at all. That's my wife. That's my kids.
Mark Wahlberg starred in it.
Professor Nolan, just make one about a cat. Solved.
I should do that.
You think I'm kidding?
Engineer.
Be like, this is what kept me sanity. This is Toaster.
Yes. You should make a movie, Noah.
She will not be appreciative. I need you to sit here and pretend to like me for 5 minutes.
Oh, she loves you. Noah's cat is named Toaster. So, anyway.
What class is this?
I'm sorry?
What class is this?
Digital Logic Design Review.
Yeah. I just dropped in, so I was wondering.
Would you like to offer any words of wisdom to the few stragglers that are still here after 3 hours?
Everything on the board is important.
It's about 4.
That's about it.
Yeah, I got some too. Please be neat. Especially with this question.
Please don't write like Noah does. Oh my God.
I give you permission to, if you still have an exam, to show them after.
Yeah, I probably do somewhere.
I think they would appreciate it. It's abysmal, guys. It's really funny. It's kind of sad.
Please make sure you write legibly. And above all, what do you do if you have a question?
You ask him. He'll answer him.
I will.
Unless you go, what's the answer? And then he'll just be like, that's not how this works.
And the other thing I would say, interact. It helps.
It does. Most of the gals interact, so that's good. Yeah. Some of you guys really, really, really need to step up your game.
No, I have a question real quick. Are we
yeah.
So I'm still thinking about like what I missed before I came here. We were talking about the consensus theorem, and I was wondering, is that something that's going to be on the exam?
I wouldn't normally. The answer is no. That's your reward for tuning into the review session. You don't need to know what
an opportunity, not an exam.
Yes, that is very true. It's an opportunity.
No matter what, the answer was no.
Yes. So, Kylie, That's my gift to you, but I'm sorry you're going to fail because you called it an exam.
So am I don't know if I'm off, but I don't remember anything consensus theorem being mentioned like in lecture.
It was on your homework. It was a homework problem.
Okay. I think
And I might have done it on the board. I remember doing it on the board, I think.
Okay.
Didn't I?
You probably have. You have a really strong memory.
Does anyone remember me working out a problem like that on the board? I think I did. Because I remember converting it to standard sum of products form and just starting to cancel terms until we got to the expression that was on the right hand side.
I was just wondering because I had missed it, so I didn't.
I understand, Kylie. I understand. And I certainly hope your day has gotten better over the past couple hours.
Oh yeah, it was just a long pharmacy trip.
Yeah.
We went. I had to take my boyfriend to the hospital yesterday, and
Oh man.
Yeah, they're usually like the Meyer pharmacy out here is open 24 hours, but it wasn't. It's open till midnight, so I was like, okay, their pharmacy might still be open, and it wasn't. So then we had to drive all the way out there today, and they had like split our thing so that one thing was at Meyer and then the other thing was at Kroger on the other side of the town. So
Really?
Yes.
That was fun.
Took very long. I left like an hour before the session because I thought I would have more than enough time. But then
Right. Yeah, I did get your message. It was the pharmacy trip from hell. I'm sorry.
Yeah.
I'm sorry. Well, I hope your blood pressure is somewhat reduced by now.
Me too.
You're welcome. Anything for you, my dear. Guys, you didn't ask anything about it. I did mention it. You might have thought it was in passing, but it really wasn't. Make sure you know your binary arithmetic, okay? That's stuff we did at the beginning of the semester. Okay? All right. Know how to's complement, sign binary works, all that kind of stuff. Know how to multiply.
Everything. I just need to get much better at Boolean algebra.
You will. Remember, I will give you the theorems, not the theorems, the 12 rules of Boolean algebra. There is a question on there about simplification, okay? Using Boolean, the 12 rules. I will give them to you. You do not need to memorize them. Okay? And somebody asked a question in the chat earlier today about what about the postulates and theorems that we looked at in the very, very beginning of Boolean algebra. Well, the 12 rules encompass those, right?
Yes.
Those 12 rules are based on the theorems and postulates. So, no, you don't need to memorize them. Okay. And as Jonah and everybody else who has had me before, I am not a fan of making you guys memorize stuff. Okay. This class is about problem solving. It's not about whether or not you can remember what Rule 12 is. Okay.
It gives you more practical questions for real life applications. In my personal opinion, you give us more questions that are more practical to real life situations.
I like to think so, right?
Yeah. No, I'm agreeing with what I'm saying. This is what you're doing because after my co-op, that's what I found.
I try to give you the foundation so you can actually get stuff done when you go to do this in real life. That's my goal. That's my goal. Whether I accomplish it and or you agree with my goal, that's a different matter, but that's what I try to do. So, okay. So I told you about, you're just going to download the opportunity from Blackboard, right? Did I tell you that? I can't remember.
You posted it in the chat.
I did post it in the chat. You don't need to tell me when you want it. You just go get it when you want it. Okay? That'll start the timer and all that kind of stuff. So,
what about that 24 hours?
Yeah, I knew somebody was going to ask me about that. You're going to get that from Blackboard too. I think I pinned a message in the chat as well on that. You're going to get that from Blackboard as well. And the 24-hour clock will start when you download that. Okay?
All right.
Make sure that you do your final submission before, I think we said 11 p.m. or midnight. I can't remember. On
You said
Friday,
11 p.m.
11 p.m. Friday evening. Okay. If you turn it in later than that, I don't have much of a choice, but impose a penalty for a late submission. Okay. It's just not right to the guys who leave stuff blank but turn it in on time. It's not fair to them. So, if you're a couple minutes late, I'll let it slide. If you're 30 minutes late, there has to be a grading penalty. What else? That's really about it, guys. That's all I can think of. Can you think of anything?
Concerning the time to grading penalty, if we complete it within the allotted 3 hours, but it takes a little bit of time to scan or otherwise get ready, would that still accrue the penalty?
Yeah.
Nice.
3 hours includes scanning. It includes time to download to when it's submitted. Okay.
All right.
It's I think it's 9 or 10 pages total. One of which is the cover page. Okay. And a couple of your classmates had to take it early. There's no choice but to take it early. And it took them less than 3 hours. So I don't want you to, be totally frazzled. Okay.
Makes sense.
All right. Now, it doesn't mean you can take your time and, go out to, hey, I'm halfway through this thing and I really have a craving for a burrito. Oh, Chipotle has a half an hour wait. Oh, well, I got time.
There's always time for a burrito, as long as you do the work in the line.
Oh, yeah. You raise a good point, Noah. Well, anyway, you probably don't want to spend all that half an hour getting your much beloved burrito. Probably don't want to waste all 30 minutes doing absolutely nothing. So, yeah. Take the opportunity with you, okay? Just don't ask the person making your burrito what the answers are.
Can I piggyback off that for a minute?
Go ahead.
If you get stuck on a question, don't ask him and then wait for an immediate response. He has the entire class. He has to answer questions too. Please move towards the next question.
Yeah.
Because if you sit there waiting, it's going to take a while.
Or, well, it could. Well, I do my best to answer your questions as soon as I can. Seriously.
Yes, that is the truth.
Tomorrow is a work day for me, and we had a really important design review today, so got to deal with the fallout from that. Nevertheless, I will get to you as soon as I absolutely positively can. All right. The question, God's honest truth.
Yes.
The questions are not necessarily related to one another. There's a couple that are, but it's not like, oh my God, I haven't finished number 2. so I can't finish anything on the rest of the opportunity. That's not true at all. That's not true at all. You can skip that question until you hear back from me, okay? And again, if you get stuck and you are having a brain cramp, I don't remember. I don't remember how to handle this situation with Petrix. Oh my God, I'm going to fail this thing. Guys, just go to the next, let me know, okay? And while you're waiting for a response, go to the next question like Noah says, okay? More than likely, I will not give you the answer to this, but I will tell you how to get there. And Noah and whoever else has had me before should definitely echo that.
Yeah, no, there's been many moments, especially in statistics, when I forgot what 1 + 1 in binary was, when you're like, come on, let's think this through.
Okay? All right, guys?
Alrighty.
I will hold your hand, seriously. I will hold your hand as much as I can while still, I do expect you to think, right? I know that's cruel and unusual punishment for some of you, but I do expect you to think. That was a joke, really? Nothing? Seriously?
I cannot give you any certain expectations on whether or not I can think, but I'll give you my level best.
Oh no, he's learned that
That's
I
all
can't
I ask.
I'm
That's
just
all I
having a class.
Give it your level best, okay?
We will.
What's that, Kylie?
Sometimes it's so easy to think until you take your exam, and then brain stops working.
Well, if your brain stops working, let me know again, and I will do what I can to jumpstart it. How's that?
Sounds good.
Much appreciated.
Noah, were you saying something?
I advise caffeine if your brain stops working. That's what I do.
That does help, yes. Was that Brooke?
No, it's me.
Oh, that's right. You got one in the oven. Yeah, you're probably not supposed to caffeinate them, are you?
Yeah, I'm a little zooted.
What's that?
I don't advise caffeine then.
No.
There's actually a limit. I didn't know until I got pregnant, but you can have a little, just not like you can't go crazy. But I try to avoid it.
Yeah.
Maybe a nice herbal tea then. I don't know, man.
You're gonna make a wonderful mom.
Thank you.
You're welcome. Any other questions, guys? I gotta get some dinner.
Oh yeah.
No, you pretty much checked off every single box I came in expecting to ask.
Yep.
Okay, cool.
I think I'll still have a little time tomorrow to review in the gap between the career fair and let me to take it at 5, so
okay.
If I have any panicked questions, it'll be then. Thank you so much
Alrighty.
for the time and attention. I'll be heading out now.
No problem. No problem at all. You're welcome, Kylie. You too. Anyone else?
Thank you. I have a quick question.
Yeah.
Since I came in a little late, was Boolean simplification discussed in the beginning at all?
Not much. The Boolean simplification that we did go through, well, we did the Carnot map, obviously, and went through a little bit of this, how to simplify the expression you get from Petrick's method, right?
Yeah.
How to simplify that. We didn't really cover too much. Estefan's recording this. He started about, 45 minutes into the thing because I forgot to record it. Sorry. So there'll be a recording, Chris.
All right. I was just asking because I just had like one issue with it on the homework, and I'm like, I can get it. Thank you.
Yeah, I have a feeling you're going to be fine.
All right.
Anything else, guys? Okay. Good luck tomorrow, guys. And again, whatever you do, if you have any questions, you get stuck, all you got to do is let me know.
Even on like the 24-hour portion, can we ask questions?
Of course.
Okay.
Of course, Connor. Yeah, absolutely. Okay. I might have to talk over the table saw, I guess. So there'll be a lot of racket, but I'll still try and help you out. Okay.
Okay.
Okay, guys, I'm going to call it a night. Let me know if you have any other questions, okay? I'll try and answer them in the messaging, okay?
Okay, thank you.
Okay, you're welcome. Take care, guys.